All right, hey everyone, today we're going to take a look at lesson 6-3, square root functions and inequalities. And as always, pause the video when needed so that you can go ahead and take your notes. All right, so here is our parent function of a square root. The parent function is square root of x. So here we are taking a look at from 0 to infinity is our domain, and from 0 to infinity is also our range. It is not defined for anything less than 0 for x because you can't take the square root of a negative number here and get a real answer back. So it's also not defined. We have an intercept at 0, 0 for both x and y. Our end behavior is as it goes to the right, it goes towards infinity, as it goes towards 0, it also goes towards 0. So we're going to identify the domain and range of f of x equals the square root of x minus 2. So we're going to find the domain value will include values for which the radicand is non-negative. So the radicand is what we call, the radical symbol is what we have here, what we call the square root. What's inside the square root is called a radicand. So we're going to set our radicand to be greater than or equal to 0, and then solve for x by adding 2 to both sides. So we find that our domain is x is greater than or equal to 2. So we're going to, since we have no other transformations here, we're going to plug in 2 to find our lower range limit, which gets us 0. So our range is from f of x is greater than or equal to 0, or y is greater than or equal to 0 is another way you might see it. Go ahead, pause the video to give yourself a chance to work on this problem. All right, so since you have worked it out, you should get C. X is greater than or equal to -4, and f of x is greater than or equal to 0. All right, so transformations. We've gone over them almost every single time. They don't go away. So we have our transformational form is f of x equals a square root of x minus h, and then plus k. Sometimes the plus k will actually be in the front part where they'll do k plus at the front of it, just kind of for forming the form for it. Sometimes just to make sure you also know that plus k does not go inside the radical. Our transformations are pretty much the same. H tells us if it moves left or right. Our domain generally is x is greater than or equal to h. K tells us if we move up or down. And we have two versions of the range. If a is positive, then y is greater than or equal to k. If a is negative, y is less than or equal to k for our range. Orientation and shape is our a value. If a is negative, it flips upside down. We have a reflection. And then we always look at the absolute value of a to determine if we have a stretch or compression. So we're going to graph y equals 3 square root of x minus 4 plus 2 and state the domain and range. So our minimum point, or sometimes also called our starting point, is going to be 4, 2, which is h comma k. So then we can make a table of values for values greater than 4 on x and graph the function. The shape is still the same, but because the absolute value of a is greater than 1, it is stretched vertically, and it's translated up 4 units, translated right 4 units and 2 units up. So here's a table of values that we could use. We could go ahead and plot those points and sketch our graph. Do notice that as x goes up, so does y. All right, so we're going to graph y equals negative square root of x plus 5 minus 6 and state the domain and range. So we find our starting point, h comma k, is -5, -6. So we're going to make some values for the values of x greater than or equal to -5. But because a is negative, we do know that a is reflected over the excess. So f of x equals -6. It is also translated 5 units left and 6 units down. So here is our graph. Notice that as x increases, y decreases. So we would plot our points and sketch our graph. All right, go ahead and graph the function y equals 3 square root of x minus 2 minus 3. All right, after graphing it, you should get d. You should know that your starting point is at 2, negative 3. So sometimes you do need to make sure that you do read the graph and look at how they are counting. All right, state the domain and range for y equals the negative square root of x plus 1 minus 4. All right, so we have x should be greater than or equal to negative 1. And then because it is upside down, or we have a as a negative value of negative 1, I know that it looks like this. So with that, we know y is less than or equal to negative 4, which gets us a. All right, so real world example, we have used graphs to analyze the square root functions. So when an object is spinning in a circular path of a radius of 2 meters with a velocity v in meters per second. All right, sorry about that. So we're gonna go ahead with in meters per second, the centripetal acceleration a in meters per second squared is directly toward the center of the circle. Velocity v and acceleration a of an object are related by the function v equals square root of 2a. So we're going to go ahead and graph this. So the function v equals square root of 2a. We're going to make a table and then plot the points. And that's all we really need to do. Part B says, what would be the acceleration of an object spinning along the circular path with a velocity of 4 meters per second? It appears from the graph that we'd get 8, but we're going to check. So we're going to plug in 4 for v. Square both sides so that we get 16 equals 2a, divide by 2 and get 8. So it'd be 8 meters per second squared. All right, so go ahead and graph v equals 0.094 square root of a cubed. All right, as you graph it, you should get b. What would the surface area of be if the volume was 3 cubic units? You should get a. All right, so now taking a look at square root inequalities. So we're going to go ahead and graph. Pretty much you can graph y equals the square root of 3x plus 5, and then to see what the graph actually looks like. And then because we have a less than or greater than symbol, there's no equal to, we get a dashed line. And then we can go ahead and test a coordinate point to see if we shade above or below. So since it's saying the domain is x is greater than or equal to negative 5/3 and y is greater than the shaded region, we're going to test a point. So they test 0, 0 and find that is a false statement. So that tells me I shade in the opposite region. And do notice that it has a stopping point of where for the x values, that you don't go past that point. So go ahead and graph y is greater than the square root of 2x plus 4. Right, and when you do that, you should get d. And that is the end of our lesson, and I will see you next time. Bye.